Much. Next slide, please.
Go. Yeah, go ahead.
Hello.
Go ahead.
Hello, everyone. Good morning. Really excited to be here. Thanks for joining the session. Exactly from 2 minutes from now, you will see we'll deep dive into all the technical content you have been waiting for. Just bear us with a minute. I'll just kickstart the agenda, and 2 minutes from now, you'll see all the right stuff you have been waiting for. So in this session, the current session, you will be seeing deep dives about the virtual public-private cloud portfolio, a deep dive on 3100, firewall design and sizing, and the feature overview. So these is the content that you have been waiting for. You'll see that coming in the next, just 2 minutes from now. So next slide, please. Thank you. So this is a high-level overview of how we compare ourselves on the virtual portfolio a year ago versus today. Now, if you see tremendous inroads we've made into the virtual portfolio investments, a year ago we would have been, anywhere between 40 to 50% with our competition. If you look at how we have invested, three things that I want to call out specifically, which again Tomas will be covering in the coming slides in his deep dive. Clustering, we have clustering now made available. Support with AWS and GCP, 16 node, KVM and VMware, 4 node clustering support already available with 7.2. JNET protocol support, we have launched on top of what JNET protocol does, gateway load balancer with AWS, that's already available, shipping today with AWS. On top of it, attribute-based policies, not supported a year ago. Again, we have, marked it green now. OpenStack and OpenShift support, hypervisor support, ESXi, all of this. And one thing that I want to call out, which again, Tomas and the team will be covering, is about the automation and the orchestration. I think all the Terraform scripts or CloudFormation templates that we have been creating for the past 1 year, we were way behind, with respect to all our automation capabilities that helps our customers to deploy faster. Today, for the past 1 year, what our TME teams have done, the amount of, content that we have created, which will be shared in a minute, is something commendable, and we can, we can have no doubts that we have, comparable or even more content, with respect to the automation and orchestration capabilities when you compare ourselves with, the likes of PAN or Fortinet. Like I said, Autoscale, along with AWS Gateway Load Balancer, support for the new instances in, AWS, snapshots, that's something that's probably you don't see here again, which, Tomas will cover, and clustering. These four things, something that you can talk about a lot with your customers. Just wanted to make sure that you all are aware that we are, proactively investing into the virtual and cloud portfolio, which we feel, or which the market has been thinking about Cisco's investment, capabilities or doubting about it. We see ourselves invested for the next 1 year, like Justin just mentioned. You'll see a lot of cool stuff coming in the next 1 year. You will see IPv6 support coming in the next 7.3 release. You'll see a lot of partnership announcements coming, in the subsequent releases. With that, I just want to hand it over to Tomas. Tomas, over to you.
Thank you, Durga. Can everybody hear me okay?
Yep.
Perfect. So welcome everybody. Pressure's on me, right? First session of the day. Welcome first to the virtual public private cloud. Welcome to the summit. Why are we here today? So I usually start off with something like this. We're gonna get very technical a little bit through this. We have some time, so I'll get into this, but why are we here? Well, virtual public and cloud firewalls, multi-cloud. That's the kind of main reason. I like to throw these numbers out there to kind of get people thinking really quickly. 76% multi-cloud is already here. Biggest number I always stand out is 57% of skill shortage. It's still a developing market. It's still huge. And that's kind of the reason it's the first session. So let's get started with some of the technical stuff. If you notice, a lot what Durga, Justin, and everybody's kind of been mentioning is that, we're growing the portfolio. And that's true. If you look at this, from the private cloud to the public cloud, we have been tremendously growing and performing better, right? We now have Rackspace, Akira, Alibaba. Those are coming very soon. But we're working with Equinix on the public cloud. We're working with Google Cloud and AWS and Azure and all the features they're able to provide. On the private, I did a session at Cisco Live recently on OpenStack, a huge still market. KVM, Nutanix, VMware, right? So those are still, but look at all the new features that we're also developing. So clustering, I'm gonna get into a lot of some of these deep dives. but we're not going to cover every single one in this time frame. So there's a session down later on that talks about deep dive firewall that go ahead and we'll expand on a lot more through this. But for this session, infrastructure as a code, right? We're going to talk about snapshot support, auto scaling. So let's get on to one of the first features, Cisco Secure Dynamic Attribute Connector. Now, Chris Grabowski is on my team, and he's been talking about this for a while. This is not something that's new, right? We can take CSDAC and we can put it into the FMC, and we can now put it into the cloud. It's cloud delivered CSDAC. What is that? Well, we can now take, and we support FMC FTD since 7.0. We have now started supporting CDO, hosted SaaS platform. So we supported with on-prem before, where you were able to deploy it with a Ubuntu machine and be able to take all your attributes from your multi-cloud to private clouds, populate them into CSDAC, which then automatically was able to populate that into your firewall policy. But not only that, as soon as something changed in one of your clouds, what ended up happening is that attribute automatically pushed into the firewall. You did not have to go in and log into FMC and click redeploy as soon that when that attribute changed. So now with the new feature is we can now deliver it into the cloud. So providers, why? This is huge. Multi-cloud, Amazon, Azure, right? VMware NSX attributes, Google Cloud. We can take all of those attributes within the multi-cloud. Imagine managing every single one. And it's almost impossible, right? You have so many different VPCs, different zones, everything. If you populate it through a CSDAC, and now all of a sudden with CDO support, you can have that on-prem through cloud support and be able to easily manage it. So what does this look like? Well, Cloud Delivered Dynamic Attribute Connector gives you a single dashboard. Single provides an overview of the configuration and the full status. Then you can take the policy in real time using attributes from dynamic changing cloud environments. So as soon as you populate either Azure, Office 365, whichever cloud environment you want to be able to put it, you can put that in there. Now, the beauty part of this that I like personally is we can take on-prem and cloud delivery, supports both. So if you are a customer who, let's say, embraces the full cloud, beautiful. But if you're a customer who's still kind of shaky and wants to do that hybrid concept, we can actually take that and support it with both. This is something also that I like, multi-tenant support. We can now provide it. So if you're a partner who has a lot of different customers who manages for everybody, you are able to provide this support for different customers through multi-tenancy. Now, this is really, really cool because now all of a sudden you can take all these attributes and you don't have to click deploy every single time. And we all know how much we like that, right? Spending time on that. So why is the next feature? Well, we've all know VXLAN, we all know Geneve. Well, with 7.2, we took VXLAN and Geneve and are able to support it in FTD. Now, we've all seen videos on YouTube channels and talks and everything with ASA, but now we can actually take that support, we can provide it. What does that give us? Well, it gives us one of the greatest benefits. We can now take gateway load balancers and utilize gateway load balancers. Now, first one is AWS, Azure. Right now, Azure, we still can't do it, just to answer some questions. And it's just because how Azure hasn't deployed yet. We're working through that. But AWS, it's already there and it works really nice. What is gateway load balancers? Well, let me show you a little bit in this design. I think this was up. Imagine you have an inbound, outbound traffic. Well, gateway load balancer enables to encrypt that traffic, encapsulate that traffic, and send it all the way without changing anything within your VPC into the gateway load balancer and then through your firewall out to the internet. So you don't have to do all the routing. So this is standard in and out outbound traffic. Imagine putting that in there. You set up your gateway load balancer with your firewall, and then you put your endpoint gateway load balancer within your VPCs all throughout your cloud. This way, everything gets routed into the firewall and you don't have to set up any routing. The same concept kind of applies into your east-west traffic. The only add-on here is the endpoint load balancer is within the same VPC as your gateway load balancer. And you take that AWS transit gateway And that's where you will set up your routing. So now all of a sudden within your VPCs, you set up routing through your transit gateway and be able to push that out to your endpoint, which then will go to your gateway load balancer. The other cool one, and I think again, multi-cloud, the whole concept of what we're trying to accomplish here is traffic to an on-prem device. This same concepts apply. You can take that within your VMware environments, within your OpenStack environments, and you can send that into your transit gateway, route it properly, and have a firewall in AWS that will be able to support that. Those are some of the benefits that by having Geneve support into the tunnel, which will sit between gateway load balancer and the secure firewall, we can now support all these new scenarios. So one of the new features, and that's what I'm going to kind of pause for and just talk a little bit through it, is my favorite. We all know support, right? Snapshot support. I don't think there's a person on this call, maybe I could be wrong, that hasn't some sort, in a way, worked with some sort of a snapshot, workstation, VMware, clouds, or somewhere. Well, why do we put it in this firewall? If you've ever deployed a FTD, you know that the populating that database takes forever, right? And I'm not going to hide that. Working 15 years on the partner side and coming up through SourceFire, through on a partner, and then going into 6.0, believe me, I know where you guys are. Well, we now have snapshot support in there with 7.2. What can we do with that? Well, imagine building a full dynamic cloud and all of a sudden you want to scale really quick, right? Your boss calls you or somebody says, hey, we need all of a sudden 6 new FTDs to be able to scale this new traffic. Doesn't matter what geo scenarios happening in the world, we want to scale. Well, if you're taking 45 minutes to deploy, that's not cloud ready. That's not speed. That's your 1980s where you got to, take a hammer and put some stuff up. Now, you want to be able to be agile and quick. And that's why we were able to put this in there. What does it look like? Well, I think the commands are really simple. Go to expert mode, become root, click prepare snapshot. Once you deploy, when you have your first FTD properly deployed, you will be able to prepare the snapshot, it will shut down, and that's it. At that point, you're going to log into your AWS or Azure. Now remember, the first thing that is in there that's really important that I got feedback on the first is there's no configuration in this. The configuration will sit on your FMC. The concept of this is to scale out really quick. So you want to be able to have a firewall where you can imagine like just taking in, I don't know, ASA, plugging it in, and all of a sudden copy and paste a new configuration, and that's it. From the AWS, very simple. You're going to go ahead and go to image, templates, create an image. Very important, check the no reboot button. And then as soon as you do create image, you'll get a new AMI and you're done. 5 minutes and then be able to scale really quickly. From Azure side, same thing. A little bit different GUI, still the same concepts apply. Create and review. So when you go to create image, create and review in 5 minutes again. Customers have asked me this question when we first deployed this with 7.2 is, well, how do I know which image was a snapshot, which ones wasn't? So we were able to go ahead and populate that information. As soon as you scale out, if you want to know which image you are running on, you can go to show version, and at the end of it, it will tell you it's a snapshot. Also, there's a cool command, new one, show snapshot detail will actually populate that information. Really quick, 2 new commands, but it will actually tell you everything about it. If there's a snapshot version of it's the actual one that you deploy. Again, it doesn't say the configuration because the concept of this is, imagine if you had a spare boxes and you were able to just, hey, I want to scale, physically just plug those in, rack them and stack them, and that's it. This is the whole concept. The configuration will sit on the FMC to be able to push the configuration as scale you want. Now, we're talking a lot about scalability. And I think the main concept of scalability is orchestrating security. Now, when I joined TME, I'm not a Cisco, like everybody here is 10 plus years, and that's amazing. I've been at Cisco for 3 years. I've been at NetSec for a year and a half. And when I joined, I loved one thing is I was able to kind of do the new orchestration automation team. And since joining, we were able to take and create a lot of templates. This was working with partners, with my previous experiences and everybody else And this little team that we created, we were able to create these new websites where anybody can join and go in and be able to download your Terraform template, right? Your Ensemble template based on use cases. The other thing we're doing a lot is we're creating a lot of YouTube videos, and they're not long, 30 minutes, right? They're basically scenario based or use case based if you want to almost talk about it. So if somebody wants to be able to see how to do, for example, clustering or anything like that, you can just go in and see that specific, how that concept applies. But the templates that we're creating, and we're not done yet. We are creating constantly new templates based on the scenarios that you guys will provide to us. So the one thing that I'm going to ask everybody on this is please tell us use cases. I remember when I worked at a partner, I always saw I was living in the trenches with all the customers, and I was taking all those use cases. I'm trying to apply those use cases, but as the world changes, those use cases change all the time. So update me with new information that you're seeing constantly. Now, one of the coolest features is clustering, and I kind of get a little glimpse of it in the previous one. I'm going to kind of look back here. We all know clustering. Clustering is not new. Now, if it's new to you, there's a lot of great, again, tutorials, YouTube, go to Cisco Live on-demand library, and you can kind of look into clustering. But on a physical level, what we started introducing is we can now with 7.2 introduce it on virtual clusters. And the more I talk to a lot of different partners or customers or anybody, this is one of the most exciting ones. Why? Because we can now scale the cloud into an HA. Now, not all the features, this is still kind of beginning, so not everything's there, right? Stateful is not there, but we are now able to create some sort of an HA through clustering. But it also, you can basically scale your firewalls. So the same concepts kind of apply. You have data interfaces, right, on the physical. The same thing is on the virtual. Data interfaces on each node use different IPs. We are using that concept of VXLAN, right? So by having VXLAN 7.2, this is how we can utilize this. And our command and control link, unicast for internal communication. But as I mentioned, not everything's there. Azure is not there yet, right? It's just how Azure works. AWS and GCP for public clouds are the only ones right now that support this. On the private cloud, KVM, VMware. So if you're OpenStack KVM, it's going to work. VMware, I'm running it constantly with demos, and it works very, very nice. But again, taking those templates that I was just talking about before, you can now automate a lot of this. We are working to try to automate more and more throughout. So when you're going to create clusters and be able to deploy everything, this is the concept. How does this work? Well, in a public cluster configuration, it doesn't use FMC. Little bit different than your physical, right? So if you know in physical, you would actually use the FMC. There's a bootstrapping user data. And by being technical, I will actually have a demo right after this. I'm going to show you 2 demos. And then at the end, I'm going to hand over, but I'm going to show you demos on this. And then one node registers in the public through the FMC, and then it basically discovers all the other ones, all the other FTDs. In the private cloud, the steps are very similar to the physical. You will use the FMC to register the cluster and then push the configuration. FMC then provides everything after that. So without further ado, now, my demo is pre-recorded. I always like to pause during this demo so I can talk through it. So unlike a few minutes, this will actually be a little bit technical. So let's get started. Here we are in our FMC menu. And as you can see here, I have my FTD, both of FTD for VMware. Now we're just going to start off. Let me pause this for a second. We're going to start off on the VMware just because it's the closer one to the physical that some of you are already familiar with. So if you can see here, we create an easy button. On the right-hand side, I'm clicking add and creating a cluster. Now, easy button is, I think, one of my favorite things to call this, but that's exactly what this is. In here, the cluster, if you see here, there's only 2 steps, configuration and summary. That's called easy. You're going to populate your cluster name, your cluster key, and then you're going to go ahead and populate the information for the control node. We're going to pick the first one, 8.1. We're going to type in the VXLAN information, the tunnel information, and we're going to pick the interface for the cluster control link. Now, for this one, I'm picking 02, and everything is all set up. Priority, you can see, is 1. For the second one, add data nodes. Really simple. There's not much to do. You just pick the FTD that you want. In this case, only option left. And that's it. Now we're going to click on continue. As you can see here, that's it. It gives you a nice overview of the summary that you're about to deploy. This is easy button for anything you can expect. Now, what is important in this is this starts populating right away. It's really quick. As you can see here, it's already starting to configure everything for me. And we're going to go ahead and you can see the deployment. Now, one thing is, I'm not going to go back, but you saw there's a new in 7.2 quick, easy deploy button. If you haven't seen 7.2 new GUI dashboard, please do. There's a deep dive on this later down the road today. But the easy, quick deployment, it will not take you, when you're trying to deploy or see if something's deploying, you don't have to walk away from your screenshot anymore or anything you're doing. It will just basically hover, click on it, and it's a nice, easy pop-up deploy. Okay, let's continue. So, as you can see here, show cluster information. The first node is populating. And you can see here, there's nothing else in this. Right now, we're going to go ahead and show cluster information on the second. There's still no cluster configured. As you can see, first one's already done. Second one is spinning. It's pushing out the configurations. It's pushing out everything. We get nice little pop-up information. The 8.1 is done. And here we go. 8.2 is now bootstrap successful. So now let's take a look at our CLI. Now, very important, show IP brief. You can see here, we have our VXLAN. There's our VXLAN. Show running configure NVE. We can basically see encapsulation right there. Very quickly, everything's done through Bootstrap. Easy, nothing. And there it is. We have our IP addresses and everything is populated. This is how easy it is to deploy this. This is exactly what we're talking about when we're trying to now deploy this on VMware. So there's nothing anymore that you will be able to. The cool thing is, one of my coworkers, and there's a show cluster, and now it shows us all the information. Oops. Make sure I have this right. Bear with me 1 second. This is when you're playing this back. There you go. Let's continue here. Show cluster information. I just want to show there. So if you can look at this, we have our slave, we have our master, and you can basically get all the information, IP addresses, everything for the control link IP that we populated is now in here. This is how easy it is to deploy a cluster in VMware. Now we're going to take the same concept and we're going to go ahead and fly over now to the AWS. Now in the AWS, very same concepts apply. So I'm going to click over here. Give me 1 second. Now, in here, oops, sorry. Play button is missing. There we go. Well, let's play this. And I apologize for the bar at the bottom, but I have to keep my mouse hover over that. So if you look at it right here, we have our VMware cluster, right, that we just deployed. And now we're going to go ahead and log in into our AWS. And we're going to take a look at what we have here. First thing that we need to do is configure manager. Now, we have to make sure, if you know that, do not resolve, right? So we basically have to create, because why is this important? We're going to create the keys on the FTD because we have to add it through the FMC. So if you've ever done this, you have to create the configuration, but you cannot add it through the FTD. So now we have show managers. We can see that our manager is now configured. There's no manager on the second one. So now we're going to go ahead and we're going to add our AWS cluster in through FMC. We already configured the manager. So now we're going to populate this with our AWS IP address, registration key that we just typed in. And the same thing we're going to do. We're going to create, put this into the access control policy, put it into any group, create the licensing that we need. And very quickly, we are now able to go ahead and click register. There's our unique net ID, and it's adding the device. This is how easy it is to add. Once the firewall is bootstrapped with zero configuration, it is automatically now populating it. We can now click show manager, and all of a sudden you can see everything is completed. It's registered. Now, once this is registered, you can see that all of a sudden it's populating the full, and it's going to discover the additional firewall that we need. Device change configuration, and boom, there's our second firewall. It auto-discovered it. So if you have multiple of these firewalls, it will auto-discover every single one that you already bootstrapped together. Now, this is how easy it is to add a cluster in the public cloud into your FMC. And very important here, again, sorry, excuse me by that. Fast forward here. If you look at it, all of our interfaces, everything is in there. There's our VXLAN. There is our, let's continue. If we edit this, all of the IP addresses, all the configuration is great. We can actually now configure and push policies within here. And our VXLAN configuration, there's the Geneve and VXLAN configuration. We now support this right into the FTD and FMC in 7.2. And this allows us to be able to bring cluster to private and public cloud on 7.2. With that, I'd like to thank everybody. Hopefully this was good. I apologize for the pausing, but I kind of wanted to walk it through. Didn't want to just play it and go really fast. With that, I'm going to hand it over, and we're going to do our 3100. Thank you very much.
Thank you, Thomas. Great presentation. Okay, I think one of the most exciting thing that you will watch today is the 3100. And recently we had some feedback around the summit that it should be more technical as compared to the previous years. So I'll try to find a balance between the deep dive of what has changed in 3100 that has made it a great, platform overall versus how you can easily tell your customer in layman terms what is new and, like everything in details at a high level also. So going to our previous platform history, we have 1100s on the lower end. We had mid-range, which was covered by 2100s, and then the high end around 4100s and 9300. So a little bit story or context to add before we show the 3100s. So our PM team, TMEs, and some of our GSSO folks from the POV team, we sat down a few years back. We were like, okay, what is the biggest factor that is preventing us from selling our boxes? So we went through the deals. We did RFP, we did POV, POCs, and we went through the whole list. And in this list, we can see if it was due to a specific feature, due to other factors. And features aside, we realized that one of the biggest factor that was preventing us from winning more deal was price performance. So we came up with a special requirement for replacing the 2100 based on the price performance, keeping the performance keeping the performance high based on the required price, being competitive versus Palo Alto as well as Fortinet, because Fortinet has been selling really cheap, price performance in the past. So we needed something really competitive. And we came up with the 3100 series based on that platform replacement. So 3100s were originally, sorry about that. Yeah. So 3100s were originally designed for replacing the 2100s. And when we saw the performance numbers that came out from the engineering after doing the internal testing, we realized that it can actually a little bit overlay with the 4100s, which was a good news. So realizing that we can always have a new platform with new hardware, but one of the main, problem from the software engineering perspective is we don't have any defined term for how much time we should spend on performance improvement of a specific code. So there's no standard, like if you look at any waterfall or agile, software books, like any big writer, you will see they will always talk about writing a code, testing it, but hardly anyone says that you should spend X amount of time on doing the performance improvement of the code that you specifically wrote. So we went back, we met with the engineering, we said, okay, we need software improvement. Let's just see where our packets are spending the most time. Let's try to offload as many things we can and try to improve the performance. So luckily the 3100 refresh was around the same time. We had software improvements coming in, we had new hardware coming in, and we had some other components that I will show in the next slide that actually helped us improve our performance. And one big point I wanted to highlight is if you look at the AVC plus IPS performance of the box itself, you will see it says 45 gig for a 3140, and our backplane switch for 3140 is 50 gig. So there's only 10% performance drop if you're using the 3140 with the FTD mode, which is a big improvement in itself. We have tons of customers in the past who wanted to use ASA, don't want to move to FTD because they were worried about the price, the performance drop. But if you compare now the backplane switch limit of 50 gig versus FTD running on it with the 124 byte packet size, there's minimum drop around it. That will help you migrate most of the ASA customers to use FTD also. So looking forward, we have multiple things to talk about in 3100. One of the biggest thing that would be the show stealer is the crypto accelerator. So we went through where our packets are spending the most time. We realized that the CPU is being overloaded by encrypted traffic. So we decided, okay, let's offload the encrypted traffic that is going to the CPU and let something else do that encryption and decryption part. So we came up with the FPGA and the other components, field programmable gateway array, which is not something new. If historically speaking, FPGAs and network processing unit NPU has been around for many years in aerospace, in router switches, and some people even did Bitcoin mining using FPGA ASIC chips. So basically, it has been around. The problem was they used to be expensive, and recently there have been a shortage of these components because of the semiconductor shortage. And luckily, we were able to get a lot of FPGA or the crypto accelerator for our devices, and we were able to push it with the 3100s. Another big thing is the encrypted SSD. These are encrypted by default. Whatever traffic is coming in gets encrypted. It's a bigger SSD. The log retention has been a big issue from the past, and not every customer uses a SIEM, like Splunk or something else to send the logs to and then save it. Some customers, for compliance reason, like to save their logs in the drive directly. And then Flow Accelerator has been around for a while. For our 4100, 9300, we implemented similar technology in the 3100. And on top, for the federal compliance, we have FIPS compliance of level 3, 140, which met all the requirements for it. And originally it was started by FISMA, and FISMA is now telling, from a 2014 act, what all compliance should be done as part of the FIPS. Another thing I wanted to bring up and highlight is in 2100, we didn't have the flexibility to scale it using clustering. But luckily for 3100s, we can do clustering from fiscal year 2023. You will be able to use 8 nodes to get the maximum throughput of around 250 gigs using 8 nodes. And that will make it a easy, scaling factor for us. Another significant thing that I already talked about is the higher storage as compared to our previous platform. But the biggest factor that will have 3100 sell like hotcakes is the price performance. So if we talk about numbers, there is huge improvement in how it behaves with the FTD image. There is huge improvement in IPsec. We'll go forward and I'll show you the performance improvement overall. And doesn't matter. I mean, at a higher level, when you compare the cores of it, some of the core for platform may look similar, that we didn't do much in terms of the new CPU, but these are newer version of CPUs. The most important thing that I already talked about is we identified where our packets are spending time, and this specific hardware is optimized with the software to get the maximum out of it. You can buy, like a simple example for all the car enthusiasts, if you buy a V6, a 6-cylinder engine, two different cars will have different performance, different weight, and different, horsepower and everything. If a specific engine is not tuned for a specific car, you won't get the performance out of it. We did the same, logic, talking about in layman terms, in the software improvement for our new hardware, which gives us the maximum buck for the price performance. From a chassis, I wanted to just quickly show up how things look like. So we have dual fan for efficient cooling. We have very similar structure to what we had in the past for terms when it comes to the cooling, as well as there's a higher port ratio of the network module and the fiber ports that we can use around this specific device also. And just wanted to quickly highlight the image, how it looks like, how the fans look like. And there was a really interesting meeting we were having when we were designing the 3100 from a physical perspective of outside. So we had one of the leading car manufacturer engineer actually doing the design of it from a Ferrari company. And another thing that is really cool about this platform from a hardware level is if you look at the front holes in it, which looks like beehive. Beehive naturally is the most efficient way of cooling any system. So bees naturally have a specific limit of how much temperature they can handle. That's why you always see the beehives which are hidden in trees and other places are always done in a specific structure which looks exactly like the one we have on the platform, which allows for the maximum airflow from the front to the back of the device. We already talked about the storage, but just wanted to bring it up that it's a self-encrypted drives. They encrypt all the traffic that is coming in, and it can decrypt based on the requirement. Another important thing is we also have a secure swipe, which is not shown here. So there's a federal requirement as well as some EU organization requirement that you should be able to do secure wipe also. And when you want to get rid of the specific, data sitting in the drive, you can do secure wipe also from version 7.0 and above. And you can also have a RAID 1, support is included. That means you can also have a online insertion and removal of the drive. You can simply plug in a new drive. It won't interrupt your system. You don't need to do any reboots while doing this. Talking about clustering, so clustering is set for year FY 2023, and unlike 2100, we didn't have clustering in it. Now we support clustering for up to 8 nodes using the span mode clustering only for time being. And as the box doesn't have any FXOS or chassis manager, you should be able to configure the cluster deployment directly from the FMC. So a quick, higher level details of how you do clustering in currently 9300, 4100, what we can do in 3100, that it has to be done from FMC. There's no FXOS, there's no Firepower chassis manager. But from a functionality perspective, we are testing it right now, and it's really easy to do a clustering from FMC directly. So talking about NPU accelerator, the new semiconductors that we are implementing pretty much in router switches and firewall and multiple places. So originally talking, the field programmable gateway arrays were really expensive in the past. That's one of the reasons. If you see any FPGA, they were really expensive in the past. You will buy any Bitcoin mining or any other hardware, they used to be really expensive. But with time, the FPGA prices have gone down. We have also internally figured out how we can actually use FPGA to the maximum, what all things we can offload using FPGA. And just in layman terms, FPGAs are basically useful computation is computation plus memory. You can program how to use this specific computation and memory in a specific data plane of what you can offload. So one simple example is we can offload IPsec traffic. IPsec offload in 3100 is done using FPGA. We have multiple FPGAs. IPsec offload is done on one of them. We have Bootstrap FPGA. So there's multiple FPGAs being used in our platform, but those are all at the hardware level. At the front end level of a customer or as a normal user, you won't be able to see much difference. The only difference you will see is that there's a significant performance improvement when it comes to the normal throughput as well as IPsec throughput. From our internal, perspective, we have some flexibility around how you can configure it. We can tell it what to do, what not to do, provide us some debugging, capabilities, as it doesn't, have a whole take on the data path. It works before the data path actually goes to the CPU and other places, so it's kept separately for the same reason. So the NPU, another point I wanted to bring up. So NPU, network processing unit, we have another full form, which is neural processing unit, which is used by Tesla and other companies related to machine learning and artificial intelligence. But when it comes to the firewall and other places, the NPUs are network processing unit. So network processing units are again semiconductors. They are easy to configure. You can configure them for multiple things. They came up in early, 2000 years when it came to the analyzing of how CPU can be used for specific network queuing versus what other alternatives we can have for having efficient network queuing. The NPUs were something that came hot, and then obviously the reason being is if you're doing a heavy gaming, let's say you won't do gaming on a CPU. You buy a NVIDIA GPU and or AMD GPUs, and then you do gaming using the GPU because there's specific hardware components that just work better for doing X task as compared to the Y task. So at a higher level, NPUs, the network processing units, are really good with QoS profile. You can configure it. It also helps avoid any backlog of the traffic queues. You can have it work with the FPGA to shape the traffic, what to offload, what not to offload. Those kind of things help with the decryption and encryption, both when it comes to the traffic that is coming in, going out, as well as look at the cumulative, per module stat of the frames coming in and those kind of things. So when it comes to refresh, I already mentioned the price performance is significantly improved for 3100. That will make it easy for you to put it in pretty much in the range of firepower 2100s as well as some of the firepower 4100s. So the 2130, at a higher level speaking, this specific configuration of migration from 2130 should be around 3110. For 2140, you can migrate them to 3120, and 4110 and 4115 to 3130 and 3140. If there is still some conversation where a customer needs, clustering, and when it comes to the multi-instance, so clustering, as I said, is already supported for this one. Multi-instance is not supported for time being in the year 2023. So I wanted to clear it up. We have 8-node clustering that is already supported. We have multi-instance that is not supported right now. So if some conversation comes up regarding multi-instance, we still may have to use 4100s for this specific reason, unless we provide multi-instance in 3100, which will be around fiscal year 2023. So as I was talking about the analysis we did with the PMs and engineering and some of the other team members from the engineering team, we gave them a specific requirement that the 3100 should project these kind of performance improvement. But when the numbers came out, they were actually better. And if you compare them, they are almost 9x, as we have mentioned it before. With the future version coming close, I think these numbers will improve by 10 to 20% also for IPsec. So those are the minimum supported version for FTD and ASA for time being. And I will pass it to the firewall design and sizing topic, and Chris will take over from here. Thank you.
Thanks, Harneet, for the good news regarding 3100s. Let me share my screen. And I'll start with the firewall design and sizing. And guys, the goal of this is to run you through 2 sample scenarios to provide a design and sizing structure. And at the same time, we want to discuss areas that we've seen a lot of questions about coming from the field in the past. So we'll go through 2 scenarios, and we'll try to follow the standard design methodology. So at the end, you should be able to reuse it in your engagements. So first, you need to identify the business requirements of your customer. Then you need to map them, translate them into challenges and technical requirements and features, so to be able to position the Cisco Secure Firewall as the optimum solution and articulate the benefits and the differentiators. We want to help you understand also the scaling exercise so that once you propose a solution, it will withstand the customer traffic flow as the firewalls are deployed into the actual production network. So we'll start by walking you through the first scenario. That's going to be a financial institution. In our scenario, we're dealing with a financial institution that's serving 10 million customers and currently supports also 40,000 internal users. The actual trigger for the migration is the need to modernize the data center, and as well ASAs that are currently using is running end of life. And the customer wants to shift to the next generation firewall and zero trust segmentation, as they're already running into problems with managing their firewall policy, as it's still using the static objects. One of the important requirements is to scale to 100 gigs instantly, and then over time in the midterm to reach 400 gigs of traffic per second. And as usual, with financial customers, we already have direct competitors having active conversations in parallel. So let's start with the challenges. So we have the firewalls ASAs running successfully. However, they're reaching end of life, and that's a good moment to talk about a replacement for the next generation firewall. The customer needs to support the asymmetric traffic as they're using cluster already with active design, and we need to support the asymmetric routing with their network. The next generation firewall is required to support advanced layer 7 inspection, as well as they're complaining that the nature of their policy is too static and they want to make use of the dynamic attributes. One of the important things is to be able to migrate the existing ASA multi-contexts into the new solution to preserve the same level of segregation between the administrative, the logging, and so forth. And we've got the information that the expected average packet size in that network is 800 bytes. And that's actually a very, it seems it's very little or a small information, but it really gives you understanding on what is the approximate profile for that particular network. So we always recommend to ask for that particular data. Now, in terms of the customer goals, they want to start with 100 gigs per second, but they expect to grow pretty fast to 400 gigs. So we will want to design the solution to support the maximum required bandwidth and ensure that they can scale up in the meantime. So we need to preserve the active DC support that's already in place today. And we want to introduce the new security features, application visibility, IPS, threat feeds, all the good stuff we have with the FTD and the dynamic policies. And as they already have the multi-instance, we need to keep this model with the change management, separate software maintenance, as well as fault isolation. So now as we know the business requirements and challenges, now we can have a closer look at the current solution and try to formulate the technical requirements for this design. So currently we have 2 clusters of ASAs running into different data centers. So there is like 4 nodes in each of the clusters. One of the clusters is running in production network, the other one is the pre-production and development. And they already have 12 contexts running in that network. The features used within this installation is pretty well suited for the for the clustering, as we have static routing, we don't have any NAT or VPNs. So there isn't much that will interfere with our cluster controlling scaling. And of course, they are using the centralized management, and we need to provide similar functionality. So in our solution, we want to ensure that we will provide 100 gigs from the very beginning, and we allow the customer to scale to 400 gigs over time. We'll provide the centralized management and provide all the next generation firewall features, along with the dynamic policy, leveraging the dynamic attributes. And as they're using the context, we cannot directly translate the solution into the next generation firewall world, as this is an ASA specific feature. So we will try to find some similar replacement feature set that will allow them to keep the same level of functionality. And what's also important is the ease of migration. So the firewall migration tool will also come handy. Okay, having gathered the technical requirements, now we can map them into the secure firewall features. So let's start with the multi-tenancy support. So as they mentioned, the customer mentioned they already have the multi-context ASA configuration, right? So from the FTD perspective, we have 3 different levels of virtualization that we can propose. First being the multi-domain, where each device or an appliance running on a Firepower chassis can be added to its own management domain with own firewall policy, logging, and troubleshooting. So that's kind of the management level virtualization. Now, if we go one level below, we have the Firepower 4100s and 9300s supporting the multi-instance, where the whole device can be divided into individual, highly separated from each other instances running at the same time. This is kind of a control and data plane isolation, because essentially the resources on the box are sliced to create new devices running within it. And the last but not least, the VRF virtualization, which is only the data plane in which we simply divide our firewall into different routing instances. However, this whole box is still using one common policy. However, we can configure the per zone or per VRF specific firewall rules. Now, the clustering feature can address 2 of the requirements, the scaling and the active data center design. So the clustering by itself combines multiple devices into one logical unit that acts as a single firewall. And the state of each session is backed up in each of the sites locally, as well as it's backed up to the secondary site. So we're providing a very high available solution, even on the data center level. And the good thing is that the firewalls are utilized at the same time, which comparing to the standard active standard design, where half of the firewalls are just idle waiting to start working in case of a failure, you can provide N+1 resilience, but just adding one additional firewall. That's a strong differentiator for our design. And it also supports pretty well the asymmetric traffic design, as the cluster by itself inherently symmetrizes the traffic passing through the firewalls independently which site seen the first packet. And we can scale as we grow, right? So we can start with 100 gigs, and then we can add new firewalls into the cluster without refreshing the hardware and preserving the design that we proposed. So again, it's really good feature for our scenario over here. And as we insert the firewall into their data center, we can provide 2 insertions points. One for the north-south traffic, which is usually a transparent firewall design, and east-west, where the firewall becomes the first hop gateway of the VLANs in the data center, and then it's deployed in the routed mode. And the good news is that we can support multi-instance with the clustering starting from version 6.6. And as we go to the multi-instance with clustering, there are several things you need to take into consideration. First of all, there is the minimum required version, which needs to be taken into consideration. And then you need to remember that you can only share the cluster controlling and management and eventing when using clustering with multi-instance. However, the data interfaces cannot be shared. So each instance has to have its own dedicated data interfaces. And also there is a couple of things that you need to remember, like there is no flow offload support, and all three modules within the chassis has to belong to the cluster itself. So for example, if you have 3 modules, you cannot just configure 2 of the modules belonging to the cluster. And one thing that might become useful is that you can use different hardware models building multi-instance, as long as they are either 4100s or 9300s. Another important requirement by the customer is to go away from the static policy and managing the policy using kind of an on-demand manner, where if there is any change, you need to go to the firewall, deploy the policy, ensure that the new objects are up to date, and so forth. Now, with attribute-based policy, what you can do, you can start ingesting the intelligence from the external systems and use them within your access control policy, whether that's Identity Services Engine or your cloud providers, ACI, EPGs, and ESGs, as well as Google Cloud, Secure Workload, SecureX. All those attributes and all the state of the virtual machines running under control of those systems can be provided to your firewall and updated without policy installation, without policy deployment. Now, if none of those integrations is enough for you, you can always bring your own custom integration using OpenRest API. So the Cisco Secure Dynamic Attributes Connector comes in 2 flavors. The one that we recently launched is the cloud-provided CSDAC, where running within the CDO can provide the dynamic attributes to the cloud-delivered FMC, as well as the FMC running on-prem. And the only requirement here is to have the Secure Device Connector installed in your network. Now, the second one that was already available starting from 7.0 is a CSDAC running on-prem within the Linux machine. So in this case, the CSDAC reaches to your public cloud and provides the updates to your FMC locally. So having the attribute-based policy, your firewall management becomes much easier, more secure, and much more scalable. So instead of having static objects, you start having the elements of your policy that can tune themselves as there are changes detected throughout your network, whether that's Secure Workload, defining the policies for you, whether that's IaaS with the device profiles, with locations, with AD users, SGTs, whether that's VMware, Office 365, and other public feeds, as well as SecureX workflows that could provide dynamic objects as well, and the REST API with custom application. So now let's go to the sizing, which usually brings a lot of questions from the field, and let's try to size this solution. So we start with the performance estimator, and the first task to do is actually to understand what is the average packet size. So as we've got from the customer, we're talking about the 800 bytes of the average packet size. So what we do, we'll first try to understand what is the bandwidth that a single device can support without exceeding 80% or reasonably close to 80%, passing the traffic with the base firewall as well as the IPS. Now, having this information, we can calculate the bandwidth that would be supported by our cluster. Now, the tool already supports clustering to a certain degree. However, with 7.2, we introduced 16 cluster members, and that's not yet implemented in the tool itself. So for now, if you have more than 6 cluster members to assess with the performance estimator tool, you need to do it manually, as with this formula over here. So what we're saying is that if you have a cluster, then by default, with the optimum conditions, you will have 80% of the overall throughput of the overall sum of your firewalls within the cluster due to the penalty for the cluster control. Right. So the actual formula is pretty simple. You need to multiply the number of the members of the cluster times the maximum throughput supported by a single member and by the scaling factor, which is 80% in our case. And also, while building and designing the network, you need to remember that the MTU on the cluster control link need to accommodate this additional header of 100 bytes. And you need to cater for the worst case scenario if one of the chassis goes back and all the connections processed by that unit has to be rehashed to the rest of the network. Right, so if we look at the calculations, we have the calculation for our 800 bytes, which results in 60 nodes required for the cluster. Now, if we compare it to the datasheet number, it's really a huge difference. We have only 8 of the firewalls required for the datasheet. Now, this huge difference results from 2 things. First of all, this is 1024 bytes, so it's 25% more than the actual customer average packet size, as well as the datasheet numbers cater for 100 CPU utilization of the firewall. While in our calculations, we went much more on the safer side with only 74% of the utilization. So if you compare, so this shows how the datasheet differs from the more conservative approach if you're using the next generation firewall, performance estimator. Now you need to remember that having deviations from the optimum design, like using NAT and PAT, elephant flows, a lot of asymmetry and so forth, will also impact the performance of this cluster. Now looking at the multi-instance, if we want to employ it in our design, we need to remember how the cores and how we slice the firewall into instances. So we need to understand that the cores running assigned to the whole system are divided into the snort, into data plane or Lina, and there is also a portion of the cores that are associated with the chassis itself. And we also need to cater for a couple of cores for the system itself. So now this affects how we divide the chassis into instances and how can we estimate how much performance each of those instances has. So to do the calculations, we need to divide the overall device throughput by the number of cores to see how much bandwidth is supported by a single core for both snort and the data plane. So here we divide 68 gigs per second, which is the datasheet value of this firewall, by 64 cores, and then we know that a single core can do 1 gig of traffic roughly. Now for data plane, for Lina, if we do the same exercise, we see that it's 1.5 gigs per second. So now as we build a multi-instance, we need to also calculate whether there is a limiting factor on the Lina or on the snort side. So in this example, if we take 20 core instance and carve it out on our 9300, there will be 2 cores for the management, 8 cores for Lina, and 10 cores for the snort. So now using the formula to calculate what is the maximum bandwidth that the Lina can do, we'll get the following. Right, we'll take the 68 divided by 44 Lina cores times 8 Lina cores, gives us 12.3 gigs of traffic that Lina can support for this particular 20-core instance. Now, if we do the same exercise for snort, we'll find out that it's actually snort that will be our bottleneck in this design, providing only 10 gigs of traffic. So that's a pretty interesting way of understanding how the instances carved out from your Firepower 9300 will perform. Also, we need to take into consideration that having multiple firewalls, they will start generating events that will hit our FMC. And it's not a direct requirement by the customer. However, if we calculate how many firewalls we have running at the total capacity, we'll start seeing that we need to take into consideration the event per second supported by the FMC and the capacity of the external SIEM server. So if we look at the 16 boxes that we would like to offer for this design, we'll see that the estimated login volume as well as the event rate produced by all those firewalls will overwhelm the standard capacities of the FMC. So the kind of this hidden requirement is to have the cell logging options included in this design as well. So kind of to summarize what we can suggest to the customer, we're showing three different options. The first one, having a native cluster without multi-instances with 6 chassis, 16 modules, and converging everything into a single instance. Now, all the virtualization that was done before would have to be performed on the VRFs, which might not be possible. So for that reason, the second option assumes that we will use the multi-instance feature and also converge this development cluster with the production cluster on the same 16 nodes cluster. And the last option that we can propose is to preserve the ASAs as they are today with minimal resources required to migrate and add an IPS cluster on top of that. However, if we look at the recommendation, we would go for the second option with the fully isolated instances running on the cluster and only use VRFs in case it's absolutely required. And also introduce the RP-based policy to ensure we have dynamic objects and much easier management for the firewalls. And of course, we need to include cell as the logging with such huge cluster. Now, the rest two options are not that favorable, as generally the VRF will probably not support the requirements of the customer, as it doesn't provide the full isolation. Now, on the other hand, adding the IPS on top of the ASAs, it's an extremely complex design, and it's not that much recommended due to the problems we've seen before. So with that, I'd like to hand over to Sumit to show you the government organization use case.
Okay, I'm going to share my screen now. All right. Hey everyone, my name is Sumit and I'm one of the TMEs in Security Business Group. So for my section, I will try to cover a use case or scenario that we have created for a government organization. And then I'll finish it off with the sizing section as well. So let's jump in. All right. So in terms of customer profile and business requirement, we have taken an example of a government organization. They're trying to expand security to their 120 remote sites with over 50K employees spread across different ministries or departments. They want a single pane of glass management, centralized management and visibility to manage and control their 120 remote sites, which is expected to increase further with more users. And they also want to standardize their branch deployment for the next 2 years, keeping in mind all of their current and future requirements. Right. So in terms of challenges that they're facing today, all the branch traffic that they need filtering and access control for, it's being sent to a central headquarters site. And this backhauling of traffic basically causes increased bandwidth utilization as well as increased latency, which takes an impact on overall application performance or user experience. The customer is using multiple ISPs as they need redundancy, but there's no way they haven't found a way to utilize all the ISP links and aggregate them. Another big challenge for them is sometimes they have low-cost broadband links which can face high ping loss or high round trip time, and there's no way to dynamically switch the traffic to another ISP to make sure the user application experience doesn't suffer. In terms of remote onboarding, they have branches where not everyone in their workforce is very adept or technical at managing firewalls, and majority of their firewalls are basically ASAs and a couple of FTDs, and different types of firewall with different manager adds to the overall complexity that they are facing. In terms of future growth, they have around 3 gig of overall traffic, and that is likely to increase over next few years. And lastly, the ever-increasing SaaS adoption has basically resulted in their remote offices and users trying to access internet for more of their day-to-day tasks, installing unsupervised or unapproved applications, or even unauthorized cloud service usage, basically called as shadow IT or unauthorized cloud SaaS usage. And customer is basically still concerned with data leaks, which is really paramount for a government organization, and they need that visibility and control over any sensitive data leaving the organization and minimizing the risk for their cloud SaaS usage. In terms of goals, instead of sending internet traffic all across to the headquarters, they want to locally offload it, which is also called as DIA or direct internet access. Of course, it needs to be a redundant and scalable solution. And to close gaps in visibility and control, they need a firewall which can implement application-aware policies, next-gen capabilities for breach detection by leveraging threat intelligence from Talos or third-party. And along with that, they also need centralized logging for all of their firewall appliances to enforce a consistent policy across their multiple branches from a centralized manager. And last but not least, they want operational simplicity, which can include easy low-touch provisioning, reduce change control. They're also trying to reduce their bandwidth cost by offloading backhauling traffic all the way to DC, and by using a low-cost broadband links for their non-critical applications. In terms of technical requirements, we have the current requirements. We have a current solution according to the requirements right now, but we also need to keep in mind their future requirements and need to give them a future solution for that. So currently customer has different managers for ASA and FTD platform. But in future, they want a single centralized management option. And this would also push them to migrate their existing 40 ASAs to FTD over next 12 months. In terms of bandwidth requirement, they currently have a future VPN throughput requirement of around 100 megs to 2 gig, and total throughput varying from 200 megs to 3 gig. Why there's a variation? Because they have multiple branches with different branches all across, so it could depend on, it basically depends on how much bandwidth or throughput consumption they will have, and we will cover that in the next slide. So this is their current requirement, but we need to keep in mind about their future requirement, which is like they expect 40% throughput increase with the increasing user base over the next 3 years. Currently, they are backhauling traffic to headquarters using IPsec tunnel. So in future, they want to leverage local internet breakouts and implement security controls on the branch itself. The other thing that they are focusing on is they want to use dual WAN links that they have with dual ISPs, and they want to make sure that it gets equally distributed. All right, so in terms of design options, as I mentioned earlier, they have varying throughput range or bandwidth requirement across different branches. And for this use case, we have categorized it under citywide, statewide, and regional. We have seen more examples. There could be more categories depending on the requirements from customer. It could be very small branch or very large or medium branch as well. But yeah, for this scenario, these are the options. So for citywide, they need 800 megs, statewide 1.5 gig, and regional 3 gig. And all of this data this is where you can actually use datasheet or audio performance estimator tool just to look for which model should I offer them? So in this case, for City, we can recommend 1120 model with HA covering both classic firewall and next-gen threat prevention features. You could also use FTD virtual platforms in HA or cluster them together. But keep in mind, using virtual appliances would require you to maintain the UCS or any bare metal server and the hypervisor as well. So operationally, it would not be as easy as plug and play hardware firewall. Similarly, for statewide, we recommend 1140 and regional 1150. And according to the requirement, we can do centralized management for both these platforms, ASA and FTD included, using CDO or Cloud Defense Orchestrator. And CDO can also push them towards migration from their existing ASAs to eventually FTDs. All right. So how do we recommend this use case, right? How do we approach this? So the very first phase is planning. Do the planning first, be aware of what customer already has in terms of current assets, band utilization, what kind of features they want, if there's any next-gen feature do we want to enable. And for that, and just for mapping models, with the branch according to throughput or bandwidth requirement, you can use performance sizing tool. Make sure that you look for any UL announcements for that particular hardware that you're recommending. And also, something important is make sure that you look at the software support lifecycle guidelines to understand the difference between the different types of releases we have. You can call it odd and even release, which is basically short-term release or long-term release. And why is that important? Because it basically affects the EOL or the end of software maintenance date for that particular release. Then you move on to the design phase, right? And you can always make sure you readjust the design based on customer feedback. An example could be, let's say we discuss what kind of security controls customer needs here. And if they need TLS decryption or VPN traffic to be terminated on the firewall, we might need to evaluate a new box, because VPN and TLS decryption features will add to the overall performance of the box that it can give. So you might need a higher capacity device at that point. So this is why it's important to readjust the design based on the feedback that customer provides. So let's see how we can reassess our design option. Remember the future requirement for 40% growth. So let's take an example of regional branch. It was earlier rated at 3 gig. With 40% growth, it would be rated at 4.2 gig. And what you can do is you can just use the performance estimator tool, put in the throughput that you require. If you have a average packet size from customer, you can put it as customer or just use the default one. In this case, we're just using default. What kind of features you need, IPS, your filtering. In this case, we are assuming, we also mentioned that customer might go for TLS decryption IPsec. So if I include TLS decryption to be at 10%, let's say VPN IPsec to be at 10%, then the tool would suggest us to go with 3110 instead of 1150. So this is how we can actually readjust again based on customer feedback, what features do we need, and the average packet size and other criteria. We will look at other criteria as well in the next few slides. Do note that the tool shows SNOT 3 performance improvement over SNOT 2. So in case you're not aware, please do read our blog on performance improvement that we got with the new 7.x release and SNOT 3. All right. So we have been talking about the standardization of the branch as well, right? So once we create a sample branch, we have to be able to replicate it across all the branches. So here's our assessment so far. We have already seen 3100 series meets the future need for our customer in this case, and especially looking at the accelerated NG firewall, TLS, and VPN performance acceleration that Hani talked about, right? To optimize the application performance, we have to make sure that we route traffic through low latency, high bandwidth links. And how do we do that? I'm going to explain in the next few slides. It's also recommended to utilize their bandwidth efficiently by aggregating the links and doing a link selection for any applications which are latency averse. So by link selection, you could choose to go with a low cost broadband instead of going for high speed or high cost one. Do note that customer has also expressed concerns over data leak and unauthorized applications on their system. So for any additional capabilities, they might need something called a data loss prevention or shadow IT protection use case, and that can be offered with our SaaS offering. Yeah, more on that we'll cover in the next slides. All right. So we have been talking about design options, right, for multiple types of branches. So now let's try to translate this into how a firewall would be deployed and what features can cover the recommendations we have been giving so far on the per the requirement. So the very first one is the direct internet access deployment. And this is where we are basically trying to leverage local internet breakout links, as you can see over here, in order to send traffic to Office 365 app, just the SaaS application. We can just leverage our breakout links. If we need, we can also aggregate them as well. And all branch traffic or which needs to go through IPsec or headquarter traffic in this case from branch can be sent through the IPsec tunnel. And you could also use aggregate the ECMP or the VTI links starting 7.1. So you can club the virtual tunnel links and the DIL and the WAN links using ECMP from 7.1 onwards. And the other feature that is important that we talked about earlier is the application detection with policy-based routing. So in 7.1 release onward, we support policy-based routing natively from FMC UI. And if you couple that with application detection, we now have an application-aware routing feature that can send application traffic like O365 and WebEx directly over to the internet using the DIA or the local internet breakout links. Additionally, with PBR, you can choose to send traffic to a specific list of egress interfaces. So this could help you in offloading traffic from a higher quality, more expensive circuit to a broadband circuit, which can achieve the same availability and performance for a fraction of the cost. So this basically covers our link selection as well. And now some new features we usually launched in 7.2. The very first one is path monitoring, where we can forward traffic to the interface with lowest jitter value, minimal round trip time, or packet loss. And this optimal path selection is basically done dynamically, also called as adaptive traffic steering, where we are basically trying to find the most reliable path for the destination based on the dynamic factors that we just talked about, round trip time, packet loss. It'll automatically calculate them, look at them, and then steer it through the interface which has the least amount of jitter or least amount of round trip time. Again, the goal is to optimize the application performance and thus user experience in this case. The another new feature which got launched was the umbrella DNS policy in this case. And the idea is to achieve that extra level of DNS protection at your branches by using Cisco Umbrella as a threat intelligence resource for domain names, and thus enriching the existing security intelligence DNS capability that we already have on Secure Firewall. Now, this is a low overhead, easy to use option. You can also go for a full SIG deployment if you need other features, but just for the DNS security at branch, this is a easy to use option in this case. All right, so the next deployment is Secure Internet Gateway. And if you recall, one of the challenges the government organization also talked about is to protect any data leaks and control the unauthorized application installs. And with Cisco Umbrella Cloud, you can leverage features like DLP or to prevent and detect data leaks, remote browser isolation, secure web gateway, and cloud access security broker to protect against shadow IT use case. Of course, all of these features comes with a licensing cost, so that needs to be kept in mind. So in this case, if we want to create a tunnel, we'll have to create a tunnel with Cisco Umbrella in this case. And the idea is that we'll have to create multiple tunnels because each tunnel is limited to approximately 250 megs. So to achieve high throughput, we would need to establish multiple tunnels to the same DC in this case, which is Cisco Umbrella. And for that, we need something called as unique tunnel ID, which is supported since 7.1 onwards. All right, so we've been talking so far about design options, deployment options, and what features can be used to achieve customer goals. It's now time for what kind of manager do we recommend for all this? Well, we recommend CDO, Cloud Difference Orchestrator. Why? Because it can manage ASA and FTD using a single platform. It has easy low-touch provisioning using serial number of device. And we can also use it for config migration from ASA to FTD. And we have outlined basically some of the NetOps and SecOps benefits that CDO provides. And more recently, we have launched Cloud Delivered Management Center, basically which can which can manage your on-prem firewall as well. And you have an option where you can go for FMC on your on-prem FMC as just for analytics, and you can use the cloud delivered FMC for your config part of it. The idea is that it has the exact familiar user experience that you've been working on with your on-prem FMCs, and it also provides migrating your existing FMC to cloud delivered FMC as well. The benefit it provides, well, it reduce total cost of ownership and resource overhead. But that brings us to the end of design section for the second scenario. And now I want to go through few sizing and why I call it as quick start. I mean, sizing, I could discuss it for hours, but we wanted to basically create a condensed form of the learnings that we have taken from sizing issues. Of course, sizing itself demands a single session for at least a couple of hours. But the idea is here that how do you start off? Like if you get a sizing question from customer, they want to upgrade the firewall, they want to go for new hardware, they want a refresh. How do we go about sizing? What kind of questions do we ask? What kind of resources do we have here, right? So the guidance on performance sizing start with existing resources that you have, right? And some of the links are included at the end of the deck, and you can refer to them. The very first two are datasheet and the performance estimator tool we have. One thing to note in the performance estimator tool is, please do remember this is a estimator, right? So it's basically extrapolates numbers that you see in the datasheet. So the numbers that you see in datasheet and performance estimator use datasheet number as a reference and extrapolates the value, the throughput values, changes it for other average packet sizes, right? And whatever criteria that you find in datasheet, if it was done with a specific IPS policy, or if it was done with a specific condition, right, that we'll cover in next few slides. All that data is also going to be seen in performance estimator. It basically takes the same criteria because the reference is data sheeted in this case. Now, what if the numbers that you see in performance estimate and data sheet are not really matching up to your account? What if you need a complex use case? Maybe you need certain kind of NAT and PAT, you need logging servers, you might need so I see a question. So yeah, PE is basically NG firewall. PE, performance estimator, is the same. But yeah, coming back to the more complex use cases, you want to use a certain specific policy for it. So any of these complex scenarios where our data sheet or performance estimator might not be enough, well, we have a security POV team who does this day in and day out, and they have basically created a portal where you can look at all these results, and it can be sorted by platform, by features, by versions. There's a lot of good stuff out there. So of course, for our partners, I know this is an internal link only, so you guys can always reach out to us using Firestarter Partner Portal, and or engage with your account SE or TSAs, and we can help. All right. So, but this is very important. Like, consider future user traffic growth. I have already repeated it in my design section, but it's important because we have seen scenarios where a certain recommendation or sizing recommendation was done, and after a year, the conditions changed, and that is why the box couldn't really perform up to the level we expected it to. And this is why it's important to understand, like, when we size, make sure that the conditions that we are sizing with are in agreement with everyone, and make sure that you consider all the user traffic growth that might happen in for a few years, because that will at least give you an idea of where we are and where we are right now if you see an issue, and where we were at that point of time. So that capturing all these minute details is really important, because that will help you in understanding if you ever get into an issue with sizing in future. All right, and now if you still have questions, right? Well, there are ways to get to engage our security POV team as well. And they have their own limit of critical D. For critical Ds, they have their defined limit in each region, and you can open two types of POV requests. Basically, one is assisted POV, where they will basically create a complex topology for you if there is, get your devices, and if you have affinity for a particular testing tool, that can be done as well. So whenever you have complex or customizations involved, then you go with assisted POV. And the only thing is that it has a certain amount of lead time, because you basically procure devices, you configure them, you put them in a topology. It might be a complex topology, so there's always a lead time till when you start testing. An alternative is DIY vPods, which is do it yourself. And the beauty about this is a quick time to value, right? You have vPods which are already set up, and when I say vPod, it's not just virtual, it's just the name of the pod, but you can test hardware, you can test virtual. I think they already have 3100, or maybe they might have very soon. So all these 4100, 9300 platforms are there, they're ready to go. Topology is already set, testing tool is already set. They even have predefined profiles that you can run. So if you have a little bit more time on your hand, and that lead time is too much, then I would suggest this option as well. And you have HA cluster both as a deployment scenario for those testing as well. So it's really good. You can also reach out to us with the TME team. If you have any design review assistance. Of course, this is all internal again. But yeah, partners can reach out to with their sales team to us, and do refer to the submission guidelines for design issues as well when you raise a request. All right, so some important facts about data sheets, right? We refer to them almost daily, I guess, right, for sizing. Now, data sheet is important to understand that they're measured with inline pairs. Other modes such as routed, passive, and tap will have different performance impacts. Also, data sheet numbers do not consider any potential performance impact from other features like NAT, PAT, logging, NetFlow export, and SNMP monitoring. So why is this important? What does this mean to you? Well, it's important because whenever you do sizing, make sure that if customer has a certain amount of NAT, PAT requirement logging, the datasheet number won't do the justice, because they don't take that into account. And because it also depends on the amount of traffic that is being sent for NAT and PAT. We say TLS decryption, but how much amount of TLS decryption needs to happen is also important. So things like this, it's really important to keep in mind. So these are the conditions or criteria how these numbers are calculated, and these are the ones, and we have listed the ones which are not considered. So considering these scenarios, which are not basically considered, is really important, because these are the conditions under which the numbers are generated in your performance estimator and data sheet. So important to figure this out, because it will have overall performance impact on the box, and you will basically result into rating your throughput lower than what you had with data sheet. All right, so a few data points for sizing estimation. Traffic profile is really important, because based on traffic profile, it gives you average packet size. If you have a traffic profile which has lower average, which has lower payloads, it will result into lower average packet size, which will be directly impacted on your throughput. Higher average packet size, higher throughput, lower average packets and lower throughput. That's the formula basically. It's not that simple, of course, but yeah, that's the golden rule, you can say. Average CPS number is basically connections per second. Do note, whenever we talk about data sheet numbers, we have different numbers. CPS is one and throughput is one. So we don't mix these together. That means when we are doing maximum throughput testing, we will use an optimal CPS number. We are not going to use the highest CPS number, because if you combine, because we are trying to run one test with the maximum performance. And when we say maximum performance is maximum throughput, let's say, then we are running with maximum CPS. So if you combine these two, you can't make both of them maximum. So it's basically, you have to use an optimum number. When you go for CPS, only max CPS, then don't expect that your throughput will be as high as usually. So average CPS number is important, because customer might have a higher CPS, applications which actually generate a lot of packets per second or connections per second, but their average packet size is lower, because it's just it could be chatty traffic. Yeah, connections per second. I just saw a question. So yeah, it is really important to consider as well. And then of course, enabled features. If you have NAT, PAT, IPS, AMP, and TLS decryption, how much amount of TLS traffic that needs decryption, TLS ciphers keys that you're using, or how much amount of IPsec traffic that needs TLS decryption, because traffic might be coming through a tunnel, getting decrypted, but then it needs TLS decryption again because of their policy. So it's important to estimate that as well. Then the average number of rules or ACLs that you're using, and amount of logging. Logging is a can impact your performance as well. So number of syslog servers, what kind of settings do you have on syslog are important as well. And these data points are not just there for your, like when you submit a POV, this is going to help you in your customer conversations as well. So these are good data points to collect, for sizing estimation. And when we talk about average packet size, I know we'll be talking about a lot. So these are a few reference things. If you're using an existing FTD device and you're using FMC for it, you can just go to health monitor interface and you can see average packet size from there. And what if you're using ASA? Well, you can just use it works on both ASA and FTD. You can just use show traffic, and it basically is you divide the bytes per second by the packets per second. That'll give you, bytes per packet, which is basically the average packet size seen on this particular firewall for this much amount of traffic. So of course, if you clear statistics and you run it again later on, it'll give you a different number. So yeah, this is one of the other ways. So I'm at the end of the session. What are a few key takeaways? Like, try to understand customer goals, technical requirements. We've been talking about those technical criteria, how the data sheet numbers are there, what kind of things are considered, what kind of things are not considered. It's really important. Try to reevaluate, redesign based on customer feedback. And maybe they need some advanced feature. They have a specific requirement, right? TLS decryption inside VPN tunnel. This is a specific requirement. Try to use existing resources that we have for both platform and event sizing. And then try to review the conditions and criteria for these, which is really important as well. So yeah, this is the end of my session. I'll hand over to Dinesh now. Thank you.
Thanks for a great session on the sizing and the design. All right, team, I hope I'm audible.
Sound great.
Thank you. Hi, team. My name is Dinesh. I am one of the technical marketing engineer in the NetSec BU. And today I'll be walking you through some of the new features that we've released over the last couple of months in the 7.x secure firewall release version. So in our agenda, we have encrypted visibility engine. We'll be talking about elephant flow throttling along with the support for TLS 1.3, and we'll touch upon the EIGRP support on the Secure Firewall Management Center. So we'll start off with the encrypted visibility engine. As you may be aware, this was the feature that was introduced in the previous release of Firewall as an experimental feature. So this feature allows you to detect applications and the threats within an encrypted SSL session. And it does that without the need to decrypt the traffic, thereby requiring much less processing power and time. So in 7.1 release, this was purely in the monitoring mode, which gave us ability to provide information so that we could populate reports and dashboards. But with 7.2 release, we're now able to use this information that the encrypted visibility engine gathers to actually make policy decisions and actions. In terms of how it is enabled, it can be enabled within the advanced tab in the access control policy. And if we do want to view the host in the network map, we can enable the host discovery in the network policy as well. So when you enable this encrypted visibility engine feature, you get this pop-up. This tells you that there's a particular license which is required. So in order to use this function, we need a valid threat license. Now, why would you want a license here? This license is particularly required for application to process name assignments. So what this encrypted visibility engine does is it identifies the processes, and we are able to map those processes to certain applications. But if you were to just view the process name or OS details or threat detection details, no license is required. So we've got a new option in the custom application detector wizard where we can actually create new application. And once we click on this plus icon, we get this pop-up where we can go and enter the details of particular application. Note that we have an option for tag as well. This is where you can actually tag the custom app that you're creating with the encrypted visibility engine tag. So you know that within the applications in the ACP rule, you can actually select the tag and then select the particular application for an ACP rule. So once the application is created, that's when you get to map a particular process to that application. So over here, we define the application as encrypted visibility engine because that's the source from where the application is coming in. And we define the process that we want them to map to with that particular application and process confidence score. So this confidence value is from the range 0 to 100%, and this tells you whether the process that is detected by the engine contains threat or not. And we'll talk about this in the demo. Now, administrators will be able to assign, like we discussed, applications to process names that would have been identified within the encrypted traffic, and then add firewall rules to act on that traffic, again, without the need for decryption. So in this case, we support client OS detection, which is supported now within the SSL session. Now, expanding on from the Eve, we do support quick traffic fingerprinting as well. This is a relatively new transport protocol that enables TCP-like resilience and also provides security of TLS 1.3 over a UDP session. So now more and more organizations have actually begun to use this protocol. So as part of encrypted visibility engine, we support fingerprinting and analysis of quick sessions, and we can display some of the content of quick sessions, like you notice the URLs directly within the event viewer. And we'll continue to enhance these fields and these details over time with the newer releases. So with this, we move on to the next feature. Another key feature of 7.2 release is introducing support for elephant flow throttling. So if you're not familiar with elephant flows, these are the large, long-lasting traffic flows that can potentially cause duress to snort threads in a secure firewall device. So we're talking about database replication flows and events, which can be really long-lasting. Now, in this scenario, there's something called flow pinning. So what Snort does is it assigns flows to certain Snort threads for the processing. Now, what that means for us is that few elephant flows, along with a couple of normal flows, have potential to cause issues if all of those flows are hashed to a same core or a same Snort thread. So in this case, this is where elephant flow throttling helps. Now, there are a couple of considerations here. This is only for flows which qualify for deep packet inspection, and encrypted flows are ignored unless we have SSL decryption enabled. In terms of configuration, it's quite simple. It can be configured in the advanced settings section of the access control policy, and elephant flow settings are enabled by default when an ACP is created. So now we can detect elephant flows based on per flow CPU utilization in a fixed window duration, and we can also look at Snort packet drop percentage. These parameters actually allow the firewall admin to fine-tune their policies to detect the application flows. As you see in the action tab, we can either bypass or we can either throttle the flows. With this, we move on to the eventing. Now, connection events are now updated with another field called reason to display the elephant flows. In this case, the end of connection event shows the reason field based on action, whether the flow was bypassed or throttled. And please note that this particular feature is available with Snort 3 and firewall running 7.2 release onwards. With this, we move on to another feature, that is Snort 3 providing TLS 1.3 decryption support. We provide this capability with the ability to handle 0 round trip time resumption and with a couple of actions like do not decrypt, block, or block with reset. So we now have conditional debugging within this that allows matching of a lot of attributes like common name, distinguished name, server name indication, and as well as logging all of the information used to produce verdict. Now, along with that, we can also support logging time spent during the processing of the flow, because for some customers, that's certainly valuable, and whether the connection was hardware accelerated or not. In terms of configuration, it's quite simple. We go to the SSL policy and select the particular SSL policy. And within that SSL policy, we go to the advanced settings tab and then check the enable TLS 1.3 decryption checkbox. Once these steps are taken care, we move to the ACP where we enable the SSL policy in the access control policy. Just a quick note here, one of the other key improvements that we've made in this 7.2 release based on a lot of feedback is supporting EIGRP on the FMC UI. So like other routing protocols as OSPF and BGP, you can now configure EIGRP via Management Center UI, which gives you various options to configure its attributes. And with this, we'll move on to the encrypted visibility engine demo. So over here, we've got a secure firewall management center, and we've got access control policies which are configured. So before we start with encrypted visibility engine, we go to the advanced tab and we make sure that the EVE feature is enabled. So we go in and toggle that feature and enable it. Once this is enabled, this gives us the pop-up that we spoke about. So this tells us that we need a valid threat license. And once we acknowledge and enable this, we move on to the access control policy rules. Within this, we have got a rule that allows users to access McAfee to receive updates to ensure their endpoints are updated. So we go to the applications, we search the applications with the tag of encrypted visibility engine. And then we go in and do a quick filter for McAfee and select that and allow that within the rule. And as we notice, we've got a rule that says allow McAfee, and we've selected the application. Now, once this is done, this is pushed to the device. And now we go to the overview dashboard and we look at what new sections have we brought upon with this feature. So we switch dashboard and move to the application statistics. And over here, we go to the encrypted visibility engine. And this is where we have new widgets. So as you notice, we've got a new table here that shows all the processes that have been detected by encrypted visibility engine and without any SSL decryption overhead. So this gives us additional information about all the processes and corresponding applications which have been detected. So now to check particular events that have come up on the device, we go to the analysis and the unified events. And over here, notice that now we have encrypted visibility process name, the process that has been detected, and along with that, a particular application that has been mapped. Now, these are all inbuilt applications, but you can certainly have custom applications as well that you can map. Now, if we do a quick exclusion for Chrome, we see there are other processes and the applications that have been discovered by the device as well. And we can click on additional, we can click on this icon to get additional details. Now, what's noteworthy here is that we can go and do a filter. Now, in this case, I'm showing a filter based on a process named malware. And once I apply that filter, I see a lot of, let me go back. Yep. So once I apply the filter, you can notice that we've got a lot of connection events that are associated with this particular malware. And in this case, we can actually drill down further to see a lot more details. Like over here, if we go in and expand, we notice that we've got encrypted visibility threat confidence and encrypted visibility process confidence score. So this score actually governs if the application associated to the process is deemed malware or not. And these are the kind of settings that you can go in and set for your custom application as well, based on how that process or application is going to behave. So this covers our demo. And now we move on to the simplified branch features and initiatives. Now we know that Secure Firewall has been out for a while now. And a lot of ask has been around providing support and positioning Secure Firewall as a branch device or as a SD-WAN enabled device. So to enable our customers to be able to do that, we've added a couple of features in the last couple of releases, and we'll talk about particularly two of them here, which is direct internet access and policy-based routing path monitoring. So before we do that, we'll take a quick look at all of the initiatives that we had so far on the simplifying branch deployments. So we started with providing easy connectivity with the help of route-based VPN tunnels, because there are a lot of cloud-based deployments that use VTI tunnels, and that had been a consistent ask. So now we support VTI from spoke to hub that started with 7.1 release. We also started supporting version 6 for the IP and the BGP over VTI with the 7.1. And then moving on to providing high availability, we provided support for dual ISP configuration and active standby backup VTI tunnels as well. Obviously, if you're talking about a branch use case, we might have a couple of egress interfaces and we want to increase bandwidth. So to support that, we added ECMP support for load balancing across multiple ISPs and also for VTI. Please note that ECMP support for egress physical interfaces was already there. It was just not part of the FMC UI 7.1, but ECMP support for VTI was added particularly in 7.1 release. And then making the secure branch use case strong, we added direct internet access support, where we're talking about SaaS application detection by the virtue of first packet within the application visibility and control. And also supporting policy-based routing using application as a matching criteria, unlike the traditional destination that we used to have. And then we move on to the low-touch provisioning and providing support to allow device to be managed via the data interface, and also supporting auto-config rollback. And with the latest 7.2 release, this is where we have started supporting policy-based routing path monitoring. This is where actually not only providing a path, but we are also actively monitoring that path to make sure that it is optimum or not. Then also supporting umbrella DNS connector. So with this, let's move on to the first feature. So we'll talk about the direct internet access. Now, a typical branch use case is where a branch talks to a corporate head-end, and before pandemic, the usual deployments were like everything will be backhauled to the corporate head-end firewall, where the traffic will take U-turn and then it'll be sent out to the internet. But as we all know, things have changed. Now, the way the customers are deploying their networks is they send only traffic which is relevant to the corporate headquarters through the tunnel. And there are a lot of SaaS apps which don't reside in the corporate headquarters anymore. They are based out of cloud. So to support those cloud applications, we have provided the feature for direct internet access. So in this case, all the traffic which is relevant to the corporate headquarters goes through the tunnel to the corporate firewall. And then all the traffic which is destined for the internet-based SaaS applications that go directly out the branch firewall over through the internet. And there are a couple of components to it. So first component is the extended access control list, where we use this ACL that calls out the application that you want to allow the flow for. And then within the policy-based routing, we use that extended ACL to determine which particular egress interface would that be going out for. So let's talk about the configuration here. It's a new entry that we've added within the routing. So you can click on add within the policy-based routing, and it gives you this pop-up. So we'll start with the ingress interface, defining where the traffic would be coming in, which needs to be routed based on the policy that we'll define. Now, this could be a LAN or WAN interface based on whether you are implementing policy-based routing in the outbound or the inbound direction. Once the ingress interface is selected, you go and select match criteria and the egress interface. So in this scenario, you could have an access control list, which is based on the cloud applications, and then you can define to which particular interface it needs to go out. In this matching criteria, we also have interface ordering. So you could define how the traffic will go out for this particular application. It could be based on the priority that you define, or it could very well be based on the order You could literally select the order for these egress interfaces, and the traffic will be sent accordingly. Now, how a typical policy-based route looks like in this flow, we notice that we've got a cloud application access control list, and all the traffic which is pertaining to the cloud apps, which is coming from the inside one and inside two interfaces, will be ECMP load balanced between the ISP1 and ISP2 interface. And only when those two interfaces fail, the traffic will be fallback to the ISP3 interface. Now, customers can very well have multiple match criteria where the first criteria was for the cloud apps, but you might have a different criteria for the YouTube traffic. So it could be that for YouTube traffic, send it through the ISP1 interface. And if that goes down, then we send it through the ISP2 interface. Now, building on top of that, we introduced policy-based routing path monitoring. So like we discussed, we had support to define how we want to send the traffic based on a particular application. So at this point, we know that we have selected the path, but the challenge is, what if that path is not optimal? What if that path is not the best path for that particular application? So in order to address those use cases, we started the support for path monitoring. So we're talking about tracking the round trip time, jitter, maximum opinion score, and packet loss statistics to make sure that the path that a particular application is taking is indeed optimum. And if that goes down, then the traffic is fall back to another interface. So this is supported with 7.2 release onwards. And in terms of configuration, it's quite simple. We go to the path monitoring, and over here, we can define which particular IP we want to monitor. So if you select auto, it will go in and monitor the default next hop for the default route. And you could actually just select peer IPv4 or IPv6 to specify the IP that you want to monitor. Now, expanding on the config that we already saw, we introduced these couple of new entities where we could actually define the interface order based on minimal jitter, maximum mean opinion score, minimal round trip time, or minimal packet loss. And this is how a typical policy-based routing would look like, where you want to send the voice application traffic through the VTI tunnel, which is ECMP balanced through the ISP1 and ISP2. And maybe for the Office 365, you want to send it directly out the egress interfaces and not through the VPN tunnel, but making sure that those interfaces have maximum opinion score. So this concludes our new features. With this, I'll quickly show you the resources that we have. I hope this session was informative. And these are a couple of resources for the cloud and for the collateral, and some of the section that Sumit, Harneet, and the team talked about around the sizing and the design and the performance estimator. And please feel free to reach out to us if you have any questions around firewalls, designs, or new features. Thank you.